So this question is an excellence question that involves rate of change. So rate of change, when it comes as an excellence, that means there is three different rates involved, or three different, in the rate equation itself, there is three different parts involved in it. So as we treat it the same as the merit rate of change questions, first you will have to set up your rate equation. It's very important you set up your rate equation. So to set up the rate equation, I first find out what is the rate that I'm trying to find. Which rate? So the rate is I'm trying to find is the rate of surface area of the water. Okay, so that's the rate that I'm trying to find, is the surface area rate. So dSA over dt. And now I need to look for which rate has been given. So I have the rate. The rate we're giving is always per 6 seconds. So this bit here is my rate. Always wrong colors. This bit here is my rate. So the rate is it's the volume of water, and the water shape is a cone. So that's the volume of a cone. So that means the rate I've been given is dV over dt. And then I need to differentiate it because it's a surface area. So it's the surface area of the cone, and there is a volume of a cone involved. It's a good idea with this type of questions is you write what is the surface area of a cone, the equation of a surface area of a cone. And I think it's in your formula sheet. Okay, so the surface area of the curve shape, which is in our formula sheet, so it's the SA equal pi r n times the slant line. The L is not written like this. It's like that. And the volume of a cone, we all know it's 1/3 pi. It's also on your formula sheet. So I need to link all of that. So I can differentiate the surface area with respect to r, and I can differentiate the volume with respect to r. Okay, and that will give me that common variable in differentiation, because you will have to see what can I substitute. So I'll just substitute it in this formula into the rate of change equation, and then we will see what we can do together. So I can do the volume with respect to r. Why I've chose r in particular? Because the r is a common between the two. And I can do the surface area also with respect to r. Okay, so you can see I've been involved three different parts, and that's what I was talking about. It's always the three different parts. Now, once we got that bit, because all the parts I have, how do I know that all the part is complete now? I just need to put either multiply or divide, because dSA, yes, I do have one dSA. dt, I have one dt. The dV and the dV, dr is being repeated twice. That means I can eliminate it. So how can I eliminate it? If I flip this middle one out, this middle bit, flip it, I'll eliminate it. So how do I flip? Is by doing division. Okay, so if I place divide in here and multiply in here, and see how does that work. So now dr with dr will cancel out, dv with dv's cancel out, so it's only f dsa over dt, and that's what you want. So you know from this step is your rate of change equation is sorted. Now you want to find each part of this rate of change equation, then you can substitute it. So dv over dt is already been given to us. So dv over dt is already been given, which is 150. Now dv over dr, so I need to rewrite my volume equation with respect to r only, not r and h. So using this equation in here, I will have to find a third I find an equation that relate the r and the h. Okay, and to rate the r and h, if you notice, in every circular, remember, any circular shape, we will do the right angle triangle. That's your first step. And we said there's three things works: either the trig ratio, or similar triangles, or what did you say, Pythagoras. Okay, so now, because I have a cone and there is another, like there is a cone and inside it another cone of liquid, so definitely this one here, I'll put in green, the other triangle. You notice I have a similar triangle case. I can't use trig ratio for sure because there's no angle involved. So the only thing is our similar triangles. Why is similar triangles? Because that big triangle, the red one, so that red triangle, I have the equations for 80 and 200. But that green triangle, the small one, this is my water triangle. So this is my H and this is my R for the water. Okay, so therefore you're going to use that work similar triangle ratio. So 80 over, so similar triangle really, it's 80 over R, sorry, 80 over 200. It's equal to R over H, similar ratio. So you can use this. I can cancel this one out. So this gives me divided by 4. So that's 2, and this is 5, 2 over 5. So R, 5R equal to H. So remember, we want to replace the H with R. So therefore, I'm going to do H is equal 5 over 2 R. Okay, because I want my volume always have R only, no H, because I want to find dV over dr. So I'm going to use this one here. I'm going to see, okay, so the volume now is 1/3 pi R squared. Instead of H, I'm going to write 5 over 2 R. Okay, now I have a volume with this, so I'll have to just 5 over 6 pi R3, and now I can differentiate to find dV over dr, and that was 5 or 15 over 6 pi R squared. So rate of change is a value, so we need to find the value of that, the dV over dr, and the value of that can be found by calculating what is the R. And it says here in this, the depth of the water is 125, so the H is 125. So to find the R, so I can use this one here. Remember this equation. So R is equal to H over 5. So R is equal to times 125 over 551, and that gives me 25. So R is 50. All good. So R is 50. Now I can substitute that in here. So dV over dr equal 15 over 6 pi and 50 square. And that value is, so that will give you 19,634.95. Okay, so that's the volume. So I'm just going to put it in here. dV over dt is 150. Divide by dV over dr, which is this one here, times, now is left is dSA over dr. Now the dSA over dr is pi r. So we need to find the connections between the slant and the r, the slant line and the r. Okay, The surface area of the water, I'll just read this, the surface area of the water. So the surface area of the water is actually just the area of a triangle, it's not the whole thing. So they just want the surface area of the top of the water. So that's why the area of a circle, sorry. So therefore, this one here, I can change it to pi r square, which is easier. Anyway, so the surface area with differentiation of the surface area with respect to r, it's quite a straightforward, this one, which is good. And then we know the r is 50, so we're just gonna substitute, and that will give me 100 pi. Okay, so now I'll multiply this by 100 pi, and then now we find the answer. Okay, and the answer for this is 2.4, and it's a surface area, so a centimeter square per second. So that's excellence question, involve rate of change, and it's excellence because it have 3 different rate of change. So it's very important you set up your rate of change equation. This rate of change equation is very important. You do this one first, and then you'll find each value of that. Thank you.